So let's begin lesson 4.7, and it begins with a little warm-up, sort of just going back to parabolas and square roots, and tell me how you might take the equation of it and translate it 3 to the right. So how would you take a parabola, which is x squared, and shift it 3 to the right? Volunteer? Anyone? Liz? Good. So that would take the parabola, which is x squared, and move it 3 to the right. How would you move it 5 up? X squared plus 5. Okay, so quick review here on translations before we move to the new thing, which is which will be circles and ellipses. Square root. With reflections and square roots, how do you flip it? Over the x-axis means instead of being here, which is normal, it's here. So how do we do that? How do we get it to flip downward? Negative square root of x. Good. That flips it over the x-axis. And then what about flipping it the other way? Over the y-axis. Jackson? Y equals square root of negative x. Okay. Good. How would you get the calculator to graph both of these so that it looks like a parabola laying down? Two separate equations. One, to graph the top half, what will we graph? Square root of x, and then negative square root of x. If you graph both of those, it would show the full parabola laying on its side. Why doesn't the square root of x show you both parts like this at the same time? Because it wouldn't pass the vertical line test and it wouldn't be a function. Today, our lesson is going to explore two types of shapes on a graph that aren't functions. They're called relations. And one is a circle, and the other is an ellipse. Okay, so those are the two. We're going to learn how to graph them. And it's similar to this concept where you have to graph it in two pieces to get it to show the top half and the bottom half. All right? So, in this lesson, we're going to stretch and shrink the graph of a relation that is not a function. Again, it doesn't pass the vertical line test. Well, doesn't mean they're not important. We can still graph them. They just don't fall into this family known as functions. And discover how to create the equation for a new shape. So, the fill in the blank here is basically just this. A unit circle is a round shape known as a circle with a radius of 1. Okay, so the radius from here to here is 1. We can get the equation of that red circle by creating this right triangle on the inside and calling the horizontal distance x, the vertical distance y, and the diagonal distance, which is known as the hypotenuse. Remember that? Hypotenuse? That distance is 1, and I know that because we're on the unit circle, and the radius has to be 1. So, we derive the equation of the circle by using the Pythagorean theorem. So the circle is the set of all points going around that red shape, right? It's the set of all points that satisfy this equation. X squared plus y squared equals 1 squared. Okay? That's the equation of the unit circle. X squared plus y squared equals 1 squared. They ask you about domain and range, right? In the next part of the notes, they ask you about domain and range. So, again, the equation of the unit circle, I'm going to repeat it here, is x squared plus y squared equals, what is 1 squared? 1. So you kind of leave out that squared. The domain of the unit circle, keep in mind that it reaches over here to positive 1, and then when you go around the circle, it reaches over to what? -1. And it kind of stays in that domain. The x's never go beyond 1 or -1. So the x's are kind of trapped in between 1 and -1. So that's how we write the domain. Here's how I'll write it. Ready? The x's are trapped between 1 and -1. I'm not done. There are a couple symbols to put in there. Alligator right equals equals. That's the domain of the unit circle. The x's are stuck in between -1 and +1. If I was reading this technically, it would be the x's are greater than or equal to -1 and less than or equal to +1. That's called the domain of the function. The range is the same, except the range doesn't involve x, it involves y. So the range is the y's are stuck between -1 and +1. Inequality right equals equals. You like alligator better. Okay. Is it a function? No, it's called a relation. And can we draw it on the calculator? That's the question, and we'll answer that next.